What happened? They're gonna do better?
I think they should. I think you guys should.
Okay, so they want us to do some stuff here. They want us to, this is non-graphing calculator stuff, so, we'll just, I might pull up the graphing calculator just to do calculations. I don't have a different one up here, but we may not even need to do that. Okay, so properties of exponents. 1 to the 1/2. What is that? Well, now, we're just evaluating here. We're not solving for anything. We're just trying to figure out what that means. And the point of this is, what is a 1/2 power? It's a square root, isn't it? Yeah, so what's the square? That's the same thing as saying 1 to the 1/2 is the same thing as saying the second root, right? Because the denominator of the fraction in a power tells us what kind of root it is. It's the index of the radical. So it's a second root of 1, which is just a square root of 1. Well, what's the square root of 1? 1, yeah. Nope, not in this case, because it's square root. When we're solving for x, it's plus or minus. Okay, but this is different. The square root of 1 is just 1. The square root of 9 is just 3. Okay, it's a little different when I do a problem like this, though, where I actually have to solve for x, and I have to take a square root of both sides of an equation. Then we need the plus or minus. But if we're just evaluating, a radical like this, the answer is just 1. Okay? So. Okay. All right, next one. What about this guy?
Just do the fourth root for that.
Yeah, okay, if I want to isolate x here, the only thing I have to do to isolate x is just undo the power in this case, right? So I'll just take a fourth root of both sides. If I take an even root of both sides, what do I always have to do though? Plus or minus. Now what if I'm taking an odd root?
Then just
I don't need to worry about it, only for even roots. So in this case then x is going to equal plus or minus the fourth root of 10,000.
And we can do that on the calculator, right?
Yeah, you can.
Okay.
That's fine. On a non-graphic calculator, yeah.
Okay.
But that's just 10. If I throw that in the calculator, that's just 10. So I won't even input it. Oh, right, I'm sorry. So we have to do both, don't we? It's plus or minus. You're right. So let's practice putting that in. Right.
Oh,
Once you put them in numerical order, so we got to go least to greatest. So we'd put in, so we would put in negative 10 space 10. Okay? Okay, stepping up a little bit here, a little harder. Got a few more things to do, but we're still just isolating x. So what do we do here when we isolate x? First step is, in fact, let's do this.
We don't need to do that. Let's do cube root and then add 16.
Okay, good. Good. So if we're trying to isolate x, we're working backwards through order of operations. First add, subtract. Well, we add 6. Quentin, stop you guys. Pay attention. We don't have time for this at all. We got lots to do. X minus 2 cubed equals 2 plus 6 is 8. Okay, good. Step 1. Now, okay, good. There's no multiplication or division to do. So we'll just jump right up to exponents. We undo a cubed with a cube root. Perfect. So x minus 2 equals, do I need a plus or minus?
Yes. No, just kidding.
Nope. That's odd, so I don't need a plus or minus. Just the cube root of 8, which is 2.
Plus 2, 4.
So x minus 2 equals 2. Last step. Yeah, I get 4. Perfect. Okay? Okay, so Okay, got it. Okay, simplify the expression. Write your answer using rational exponents if necessary. So, just properties of exponents is all this is. Okay, so what do our properties of exponents say? Don't even worry about the fraction part for a second. Just regular properties of exponents. If I take a power to a power, what do I do to the exponents? Multiply. Multiply. I add, if I multiply like bases, I add the exponents.
Oh.
Right? But if I'm taking a power to a power, I multiply. So I'm just going to get 6 to the 3/4 times 1/3, which, what does that simplify to if I multiply those fractions? Yeah, 1/4. I get 3/12, or I can just cancel the 3's, cancel diagonally. And I get 6 to the 1/4. And so they want us to use rational exponents. Now, I think, does it work if I just put it in 6 to the, have you guys tried this?
No.
If I just go 6 caret, it doesn't work? If I put it in parentheses, it doesn't work?
I think, should we simplify?
Sorry, need that little thing.
Yeah, that's what I'm gonna do. You wanna do that anyway. I'm just checking this to see if it's,
Well, you don't want us to keep going with that?
you can't. 4 through to 6 can't be simplified, right? Is it like that?
Call it.
Oh, so it does take that, but don't do that. Why mess around? Why do that when instead you can just pull up this slick little handy dandy guy here and just make this, there's no point. We'll just make that 6 to the power of, make it a fraction, 1, and then we got down arrow there, so, like that, right? And then you get an opportunity when I hit accept, before I even submit it, I can look at it and see, is that what I want? Yeah, that's what I want. So make sure you use that, the little editor. Okay. Okay, number 5, same kind of deal. Simplify the expression. Assume all variables are positively valued. So, if we have x to the 1/5 times x to the 1/7, now add them. Multiply like bases, you add them, right? So we have x to the 1/5 times x to the 1/7 equals x to the 1/5 plus 1/7. And so the part here, the hardest part is not even an algebra part, it's just adding some fractions up. So if I want to add up 1/5 and 1/7, let's take a look at that. 1/5 plus 1/7. How do I add fractions?
Let's just do like a common denominator.
Good, common denominator. So I got to multiply the first one by 7 over 7. Second one by 5 over 5, very good. And then we end up with, here I get 7/35 plus 5/35 is how many 35ths? 12/35. So my answer should be x to the 12/35. X to the 12/35. There it is. Correct. Okay. Okay, what do they want us to do here? Write the equation for the inverse relation. Let's take a look at this one. There were some questions on these. These 6 and 7. Yeah, you do. You just switch the x and the y. But let's go through one of these. So if I'm trying to find the inverse of this function.
I think we talked about this.
Oh, we did. We talked about all of this, but let's review a little bit. Okay, so we're just gonna swap the x and the y, right? So that's gonna give us x equals negative 7/6 y plus 9. Now, what I think it's also not a bad idea to do is go ahead and flip that around. Put the y's on the left so it looks convenient. So it looks like you're used to what you're used to. Negative 7/6 y plus 9 equals x. Now we're just isolating x algebraically, just reversing order of operations. So what do we do first? Subtract 9. Okay. So subtract 9, that's good. That gets rid of a little bit from the left side, that's good. So we end up with x minus 9 on the right, negative 7/6 y on the left. Now what? Okay, yeah, there's really a couple things we can do. We don't really divide by fractions, we multiply by reciprocals, and that's fine. That's fine. Let's see how this plays out if we multiply both sides by the reciprocal. Okay, so if we do that, if I multiply both sides by negative 6/7, look what happens there. Then this is going to cancel all this stuff out, and I just get y equals negative 6/7 times the quantity x minus 9. Okay? All right? Joanne, you getting this back there? Okay. All right, so that's probably okay to just leave it like that. I don't see why that would be a problem. I mean, we could distribute the negative 6/7 to be real safe, but let's just try that. See if it'll take that. So negative. Oops. Negative. 6. And was it x minus 9? Is that right?
Yeah.
Yeah, it's fine. You don't even have to distribute. That's fine. Okay? Make sense? Okay, next one. A little bit harder. A little bit harder. Just a little bit more to it. And we're almost, well, we got 8 total. Is that right? No, 12 total. A few more to go.
How long's the test gonna be?
Very short.
Oh, man.
Was there 3?
No, there'll be, I'm gonna give you a freebie on the graphing calculator. It's gonna be very, very simple. You know, I mean, all you have to know how to do is just essentially graph stuff, use the graphs to find zeros. There's nothing new on the graphing stuff at all. I put up a little study guide that's 4 questions. We'll look at maybe 1 or 2 of those today, and you'll see there's nothing to it.
Dylan.
Okay, so what do I do here if I'm solving for the inverse? Where's the y? I'm supposed to switch x and y.
You're supposed to switch the Y for the F to be.
Okay, yeah, remember, and we had a couple steps to this. First, we said we always want to rewrite this in terms of y's and x's. So this is just going to become a y.
I don't know, it's just like switch to Y.
Okay, now we swap the x's and the y's.
Then you swap it.
So it's going to give us an x there. Okay, now we're just going to isolate y. We could scoot it, probably ought to flip the y over to the left side. Let's just do this one without. Algebra is the same. So if I want to get that y by itself, what's the first step?
Subtract 1/9.
Okay, good. And all we're doing, remember, let me write this up here. All we're doing is reversing order of operations, right? So we're gonna first add, subtract, so subtract 1/9. Okay? Now what? Okay.
Divide,
Divide by -3?
yes.
Okay, that's fine. So we divide everything through by -3. Now, it might be easier, instead of dividing by -3, that's the same thing as multiplying by what? -1/3. Why not write it instead as -1/3 times the quantity x minus 1/9? Same exact thing, just looks a little easier, right? And that's equal to y cubed. And so then what's the last step?
Cube root it,
Cube root. Now, if I cube root both sides, do I need a plus or minus?
no,
No, I don't. Okay, so this just becomes y equals the cube root of all that stuff. Minus 1/3 x minus 1/9, right? Okay, so now remember that. I'm not gonna remember all that stuff. Cube root, -1/3, quantity x minus 1/9. So all we have to do is put that in. Remember that. Okay, so how do we do a cube root? Well, it's right there. So we go cube root. If I want to put the little 3 up there, that's easy to do. There it is. And then we had, was cube root, what was it again? Cube root of -1/3. Okay, so -1/3 times. Okay, you got to make sure you're still under the radical there. What was it? X minus 1/9. Okay. X minus. Oops. Minus. There.
yes.
And I'm not gonna make you simplify distribute all the fractions and stuff. It's really doesn't, it's not that big a deal. We don't need to. This is the correct answer. Okay. 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 Oh, good. Let's see, what are we doing here? Wants us to fill in the blank to write an equation for the function graphed above. Okay, now look, I've given you all the key points here. I see phones away, please. Phones away. All right, put it in your pocket. Okay, is this cube root or square root? Cube root, because it goes on both sides, right? Cube root. So all we have to do is match up the information given to us by those 3 points to the a, h, and k in a cube root function. So for a cube root function, remember we have this. We have y equals a times the cube root of x minus h. Whoops.
Oh, no.
Plus k. What are the h and k?
The points,
Yeah, x and y coordinates of the special point. It's not truly a vertex, but it's that point right there, isn't it? So what are the coordinates of that point? Looks like it's -3, +2. So that's h. That's k. There's 2 of them, right? And then remember what a was. Can somebody describe for me what's a?
doesn't it say,
Intersection? No. What we said about a? We said a, if we move 1 to the right from the special point, a is telling us how far we're moving up. Positive if it's up, negative if it's down. So it's 1, isn't it? If I go over 1,
oh, yeah.
I'm only going up 1. So that's a. It's kind of like a slope in a way. It's not a slope, but it's like you're going, if I run by 1, how much am I rising to get to that point? Right? So it is sort of like a slope. So a is 1, So if I just plug that stuff in, I've got my answer. So y equals 1. Do I even put the 1 there? I don't even put a 1 there if it's a 1 times something. So I just get cube root of x minus negative 3. What's that going to look like? Plus 3, and then plus 2. And that's on the outside, right? The k is
And you
outside.
just plug that into your calculator?
All you do is plug that in down here, and that's it, right? So
Oh, no, simplify you do like that.
cube root
Yeah, there is.
x plus 3 uh-oh, what happened? I did mess up. Messed up good. This pen is doing weird stuff here. I don't know what's the deal. Been doing this all day. Cube root x plus 3. Okay, now we got to get outside, so click out there to get out. Or I think you can hit the right arrow too, I just don't have one. Plus 2. Where do you see him? Oh, right over there. Yeah, I never saw those. Okay, does that look right?
Yep.
There it is. Got it. Okay?
So it's just
I bet you. This is...
pretty.
Okay, what do they want here? They want us to write the equation for this function. More the same, right?
Yeah.
This is just a square root though, isn't it? Right? It's a square root because it's on one side. We'll make this one quick. We just want to find a, h, and k, right? So what's a in this case? There's my special point. I go over 1 and up 1, so it's positive 1. H, yeah, well, it goes off to the side. Yeah, it just, it gets cut off back there. But h is, it looks like 3, k is negative 6. Agreed? So if a is 1, h is 3, k is negative 6, then this just becomes 1 times the square root of x minus 3 plus negative 6 would just be minus 6, right? No, minus 6.
Minus
Yep.
6.
Because it's the starting point of the square root. Remember, square root, you do, but square roots don't have a middle one. Square roots have a starting point and just do that. Cube roots go both ways. Okay, that's the difference. So that's how you can tell it's a square root instead of a cube root, because it doesn't go over there. Okay, make sense?
To the left.
That's all there is to that section.
To the left.
Nope. Okay, what about this? Find the greatest real solution of the equation x to the 5/3 equals 32. Okay, not a big deal. All we have to do is undo that power, right? So let me write this one up. X to the 5/3 equals 32.
That's easy.
Okay, what do I have to do to get x by itself? How do I undo a 5/3 power? Well, I mean, I can do this in 2 steps, but we don't want it. We can do this in 1 step. How do I undo an x to the... I take both sides to the reciprocal power. Right now, think about that for a second. That's consistent with all the stuff we've done. If I have like x to the 1/3 equals 4, and I want to solve for x, what do? Well, I just cubed both sides, right? What if I had something like x cubed equals 8? What did I do? Well, I took both sides, took a cube root. I took both sides to the 1/3 power. I'm always just taking both sides to the reciprocal power. We just haven't ever really had to call it that in the past. But here, because I have numbers in the top and the bottom, we want to do that. So, if I take both sides to the 3/5 power, then x to the 5/3 to the 3/5. Well, power to a power, we multiply. Those fractions just cancel when I multiply. So I just get plain old x, right? They undo each other. X equals. Now look, the denominator is odd. So I'm taking an odd root. It's the bottom of the fraction that tells me what kind of root I'm taking. It's an odd root. Do I need a plus or minus? No, I don't. So that's just equal to 32 to the 3/5, which you can put into any calculator. We don't really need to in this case, but you can. Remember how we do these? We're going to do the bottom first. What's the 5th root of 32? Anybody know? What to the 5th is 32? 2. Yeah, 2 to the 5th is 32. So that's the same thing as saying 2 cubed. So it's just 8. But your calculator will tell you that. If I put 32 to the 3/5 into any calculator, it's going to tell me the answer is 8. Okay? Okay, last two problems. Oh, that one didn't work. Okay, well, I'll throw that one off. How about? Okay, so here's the one I want you to do anyway. Find all real solutions of the radical equation. Enter your solutions in numerical order. As decimals, rounded to 2 decimal places. Enter NA and all unused answer boxes. Okay, so we're just gonna solve this thing. And if there are multiple solutions, we've got answer boxes for all of them. If there aren't, we'll just put NA in the ones we don't need, right? Okay, so what do?
Add 1.
No. What do we do with a problem like this where I'm trying to solve a radical equation? What do we always do?
You solve the square root.
Okay, good. Isolate the radical, and we're going to take it to whatever power we need to undo the radical. Well, the radical is already isolated for you here, right? It's already by itself. So if I just take both sides to the 3rd power, well, that's going to cancel. The 3rd power cancels the cube root, right? And so I just end up getting 12x minus 28 equals x minus 1 quantity cubed. Okay? And let's see. We solve that. 12x minus 28 equals, if I FOIL that out, I'll tell you what I promise I'll do for you on the test. I won't give you anything higher than a square on the test. So we get 12x minus 28 equals, I'm just going to make this quick. If I FOIL that whole thing out, I'm going to get x cubed minus 3x squared plus 3x minus 1. Just trust me. If you FOIL that out, that's what you're going to get.
Trust me.
Okay, so now what?
That's mean. Just trust me.
Okay, so I'm going to get everything on one side. So if I subtract all this stuff, I'm going to try to make this real quick here so we can get out. So if I subtract all this stuff to this side, this is all going to go away. What am I going to get over here? I'm going to get x cubed minus 3x squared. I'm going to get 3x minus 12x. That's minus 9x. And I'm going to get negative 1 plus 28 is plus 27, right?
Yeah.
And there's a chapter 6 problem that we could just, we could solve that by factoring, by grouping. But I won't give you any of those on the test, I promise. I'll just give you smaller ones on the test. Okay, so this one we could then say, let's group this thing. Okay, then you remember this whole thing. We'll just quickly blow through this one. You guys have had a lot of practice with this. What's the greatest common factor of that first group? Sorry, put that away, please. X squared. Okay, good. I can pull out an x squared. What's that leave me with if I pull out an x squared? Quentin.
X minus 3.
Good. Right? If I factor out an x squared, I'm left with an x minus 3. We know if factoring by grouping is going to work, that has to be x minus 3. What can I factor out to get that?
Negative.
Negative 9, sure. Okay, and so then look what I've got. I can take on the left side, I've got this group plus this group. Each of those groups has a common factor that I can pull out. So I've got x minus 3 times x squared minus 9 equals 0. And then I can just set those equal to 0 and solve. So I get x equals 3, or if I set this equal to 0, x squared equals 9, so x equals plus or minus 3. Okay, so I get 3, negative 3, and 3 again. And how does it tell me to input these? Let's make sure we read the directions on this one. So it says if multiple solutions exist, no, wrong one, up here. Enter all your solutions in numerical order.
So negative 3, 3, 3.
Yeah, so negative 3 and then 3, and then we only get 2, right? So we can just put an NA for the last one. We only got 2 different ones. So I can go negative 3 and 3, and then find all real solutions. Then the other one we just put in NA. Okay, and that didn't work. I'll just toss that one off there. That's fine. That's enough. All right, that's enough to do.
We're done. We got 10 minutes. Let's just
10
chill
minutes?
here and talk about it.
When
Yes.
when a huge bomb goes off, you know that it explodes and
Uh-huh.
goes back.
Uh-huh.
Why does that happen?
Why does it what?
Like when a bomb blows up.
Uh-huh. Why does it contract then?
Yeah.
Well, typically it's because when it explodes, it's cooling, and so the air cools and it contracts, and it creates a low pressure area gradient. It sucks the air in. Then. Yeah.
Perfect one. We'll get, oh, wait. Ah.
Okay, I'm not going to do any of these, but I want you to just tell me with the graphing calculator, how could you do these? How could you do these and not have to do any work? Take a quick look. Oh, look up here. Quentin, turn around, please. Okay, how could we do these? If I wanted to do these and not do any work, remember, I can always, with the graphing calculator, I can just take whatever function is on one side of an equation and call it y1. Whatever's on the other side, call it y2. Graph them both. Find the intersections. That's all I have to do. What about here? Same thing. If I get the quantity x minus 13 to the fourth equals negative 18, 9, 9. I mean, honestly, it's probably easier just to do this one, fourth rooting both sides on your calculator, and then solving it that way. But I don't have to. I could still just graph this on one side, this on the other, find the intersections. Okay? That's it.
Is that it?
Pretty close. Let's see. On this one, they want you to choose the graph of the inverse. Okay, I was going to show you a trick on this one, but I don't know if I will. I just think I won't. What you tell me? What's the relationship between a function or a relation and its inverse? Remember what kind of symmetry they have? They have reflective symmetry over the line y equals x. Okay, there actually is a way on the calculator where you can ask it to draw the graph of it. I'll show you. You don't have to do this if you don't want to. but it's easy to do. And this is an easy way to get inverses. Okay, so we've got the graph. Here's the graph. Negative x to the sixth, where x is greater than or equal to 0. Let me show you how you can do this on a calculator. All I have to do. Okay. So if I just go up to y equals and I graph this as y1, okay, so it's just negative x to the sixth, okay? I can graph this thing. I can even do this, though. It tells me that x has to be greater than or equal to 0. Well, there's a little trick I can even do here. If I just put this whole thing in parentheses, you don't have to do this if you don't want to, but this is kind of nice, too. If I put this whole thing in parentheses, and then next to it, I can put in parentheses the domain where I want it graphed. So I could go x is greater than or equal to 0. There's x. And then behind the math menu, there's this little menu called test that gives me all these options for inequality signs. So greater than or equal to is 4. And like I say, this is kind of optional. It's good to know. Yeah, we're just trying to find the graph. And so if I go zoom, I'm just going to go zoom. I'm going to hit zoom square so it makes the screen look. Whoops, 5. There we go. So it's not skewed, it's not distorted. Whoops, I think I have to go zoom standard first. Zoom 6. And now I go zoom 5. Okay, and then it just makes it so it's not going to be stretched out lengthwise. Okay, now there's the graph of my function. If I want to draw the inverse, you're not really graphing it, it's just giving you a picture of it, but it's useful if you want to be able to recognize it. I can go to the draw menu right there. So I can go second, draw, and if I kind of go down to the bottom of the list, let's see, there it is right there, number 8, draw inverse. And so I'm going to choose that one. If I want to draw the inverse of y1, then I have to just put a y1 in there. So alpha F4, remember, gets us up to y1. That's the shortcut. And look what it does. It shows me that there's the inverse of that function. And maybe it would have been better if I would have zoomed in a little bit first. But, I mean, you can do that if you want to. You can't do anything with it. It's not a graph. It's just a drawing. But it does show you it does show you what that inverse looks like.
That's pretty cool.
Yeah, it is kind of cool. I mean, it's good to know before you go to college. Just another thing on your calculators to know about. And then, you know, the last question I could just graph this thing, x to the 6/5 on one side, -1 on the other, and just cross the two, right?
That's easy stuff.
So x to the 6 divided by 5. And what was the other side? -1? -1. Let's just go zoom 6. See what we can see. Okay, it doesn't look like it crosses at all, does it? So what would my answer be? 999. Doesn't cross at all. I can see from the graph. Okay. And on the test, I mean, I'm going to make the graphing calculator, I'll make it like 3 problems. You just have to get on there and just I just want you to demonstrate that you can find a solution by graphing. I'll make them simple, really. I'm not gonna load you up with anything hard on the graphing calculator one. Okay? I'm not even sure if I'll put one of these on there. I don't think I will. I'll just put a couple like that last one. Okay, and that's it. That's it. All right.